Oh my.
Okay. We're going to solve rational equations today. I only have 3 examples. That's it. Before we start, though, I want to show you some fractions with denominators here. Don't worry about what's on top. Just suppose there's something on top here. If I said, find the common denominator of 10xy squared, 20x cubed, y squared, 5x to the 4th y. Do you know what the common denominator would be? What would be the, or actually I take that back, the lowest common denominator, what that would be?
5xy.
No. Okay, so let me give it to you another way. What can they all divide into? What could they all become? No, not 10. They can all become a 20. 10 can become a 20 by multiplying by 2. 20 can become a 20 by multiplying by 1. And 5 can become a 20 by 4. What else? X to the 4th. What else?
Y squared.
Okay. A lowest common denominator, what you're thinking in your head because you're so used to it, is GCF. Don't do GCF. When you're working with fractions, we need the lowest common denominator. What can they all become? And it's a tricky, I hate that they use the word lowest because you think, oh, it should be 5. No, lowest really means the biggest number that they can all divide into and become. Notice though, you have to have one of every letter and you have to have the highest degree. Do you notice that? Okay, because an x to the 3rd can become an x to the 4th. An x can become an x to the 4th. A y squared can become y. You have to have of every letter and you have to have the highest degree. All right, let me do another one real quick. If I gave you this, x plus 5 quantity squared, and I was adding like x minus 3 and I was adding an x plus 5, like that. Do you know what my common denominator is here? What's my LCD here? Go ahead, Liam.
X plus 5 squared times x minus 3 times x plus 5.
No, which is a very common mistake that everybody says. You do not need to have that extra x plus 5 down here. What you're doing when you write that is you're actually finding a common denominator, but you're not finding the lowest. Okay? The lowest common denominator is everything you see, but pick the one that's to the highest degree. See, this has an x plus 5, this has an x plus 5 squared. That's just like saying this has an x and this has an x squared. You just write the highest one. Agreed? This can become that by multiplying by x minus 3. This can become that by multiplying by x plus 5 squared. This can become that by multiplying by an x minus 3 and an x plus 5. Okay, so just to go over that with you, please, 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 I shouldn't even have to go over this with you. You're pre-calculus. This is an Algebra 2 concept, but I still have students in here suffering because they're like, I don't know how to do that. So put a little star. To solve equations containing fractions, multiply each side by the LCD. These are called rational equations. Rational coming from the word fraction, ratio. We talked about that before. We did rationals, graphing them. Now we're going to solve them. Okay, here's the second thing you need to remember. This is, again, what a lot of students at your level tend to forget. You must check for extraneous roots. Check for those extraneous roots. When did the extraneous roots happen again? When was the last time that happened? When do we also have to check for them? Do you remember? It was like 2 or 3 sections ago. What was it? Square roots. Very good. Remember when we were solving equations with square roots and cube roots? We had to always plug it back in and check for those roots, those extraneous roots. Well, guys, it's going to happen in fractions because that denominator can't be 0. So if I get an answer like x equals 3, well, that would be an extraneous root because that would make this denominator 0. Can't happen. So you got to remember all this. It's rough, honestly. I remember sitting there being y'all. I was like, I'm not going to remember everything, but you have to try. All right, so this I consider an easy one. It's very, very, very easy. You should know how to do this one. I'm using the letter M instead of X today. Over 4M, okay? I'd even call this, I would probably say this is Algebra 1, because you should have done these in Algebra 1. So the first thing, and there's reasons to doing what I do, okay? I first look to see what's the common denominator between a 3M, a 2M, and a 4M. What's the common denominator? 12M. Okay. Now, I know a lot of you are going to try to make all of these a 12M. Don't do it like that. You take the common denominator and you multiply everything by that 12M. And I put it up in the right corner, and I'll tell you why in a minute. Okay? What I'm actually doing is, when I put it up in the right corner, I'm making for myself a little fraction that says 1 over 3M times, that's what the parenthesis is, 12M over 1. I just don't put the over 1 part. You could put the over 1 part if you want to, but 12M over 1. And here's why. Because 3M and 12M can cross cancel. Do you remember you doing cross canceling with fractions? So M and M cancel. How many times does 3 go into 12? 4. What that does is it gets rid of the denominator. Did you see that? That's why I don't want denominators when I solve fractions. I don't want them. So 3 goes into 12. M cancels into M 4 times. What do I do with that 4? I multiply it to the 1 in this numerator, and that's all I have left now. I don't have a fraction. You no longer have fractions when you multiply everything by the common denominator. Now I put my plus. How many times does 2M go into 12M now? 6. What do I do with that 6? Distribute it. So I should have 36M minus 54. And then 4M goes into 12M 3 times. Distribute that. 9M minus 9. Now I have a beautiful equation that no longer has fractions, and now I can just solve it like I normally would. Since it's linear, it has no squares, I'm going to get all my m's on one side and all my numbers on the other side. So let's see, this would be negative 50 plus 36m, 27m, 41. M equals 41 over 27. Done. Question. If I plug this back into the original, and by the way, you only have to look at the denominator. Will that ever make any of these denominators 0? Plugging 41 27s? No. So this is not extraneous. That works. Okay. So easy peasy question right here. Let's do another example. Let's do this a little bit more challenging, not too bad. X plus 6 over x minus 8 equals 2. So again, anytime I see a fraction in an equation, I multiply everything by the common denominator. This has a denominator of 1. Do you all agree? So does this. So the only denominator I have to worry about is x minus 8. So I'm going to take everything and I put in the corner x minus 8, x minus 8, x minus 8. If I can cross cancel, cross cancel. If I can't, I have to multiply. So there's nothing to cross cancel here. X times x minus 8 is what? X squared minus 8x. Okay. This one and this one can cancel. Beautiful. So plus 6 equals, this cannot cross cancel. So I'm left with 2x minus 16. Anytime you have a squared term that you're left with, you must set it equal to 0. Set everything equal to 0. So I'm going to keep it on this side because the x squared is positive. So what is that? 10x, 22. And let me see if I can factor. 2 numbers multiply to 22 and add to negative 10.
No.
No. So what's my answer?
It's not real.
Okay, this is the problem that everybody always has at this level. Because you're like, oh, I can't factor. No solution. Wrong. There is something else.
Imaginary.
No. Quadratic formula. Your quadratic formula, if you can't factor, you need to use quadratic formula. I mean, this is, again, don't just assume, and they're going to have as multiple choice on the SATs like, not real, or imaginary, no solution. Not if it's quadratic. Quadratics we can do. Speaking of, if you ended up like this, I would go through my table. I would look at the graph and be like, oh, is it touching? Oh, is it crossing through? If it's crossing through, it has a real number, y'all. So using quadratic formula, again, this is my 1, this is my A, this is my B, this is my C. Let's see, negative B plus or minus square root of B squared, which is 100, minus 4 times 1 times 22, which is 88 over 2. And then you need to simplify that. So that's 10 plus or minus square root of 12. Can 12 break down?
Kind of.
Yeah, to what? What is simplify to? 2 root 3. Good job. If this 2 on the bottom can go into everything up here, then you can divide it. You can cross cancel. If it can't, like if this was a 1, you would not be allowed to do what I'm about to do. Or if this was a 3. But 2 can go into 2 and 2 can go into 10. Agreed? So my final answer is 5 plus or minus 1 root 3 or just root 3. By the way, how do I know if these are extraneous or not? Well, let's look back at the original. What's the only value that would make this a 0 in the denominator? 8. Are either of these 8? No. It's just 5 plus root 3. That's not an 8. Okay? So that's not extraneous. All right, one more and we're done. See, this is easy. You got this. This is algebra 2. It's just kind of refreshing your brain on it. X plus x squared minus 5 over x squared minus 1 equals x squared plus x plus 2 over x plus 1. Again, this looks terrible. I don't want to deal with fractions. There's no reason why you guys are at this level. You shouldn't have to deal with fractions anymore. So get rid of them. And the only way to get rid of them is to multiply with the common denominator. So, by the way, if you see one that's not FOILed out or written in a factored form, let's write this in a factored form right now. What does that factor into? X plus 1, x minus 1. Okay, so looking at all my denominators, I got a 1, this one, and this one. What would be my common denominator? What could they all become? Could they all become this? Do I need to add that one onto it also? No, because this can become that. So I'm going to multiply this by x plus 1, x minus 1. And I know this seems silly, but I promise you if you do it my way, it really will help. Because then you'll know what can cross off and what will be left. Okay, so for here to here, nothing cancels. So I actually have to do x times that. Well, again, don't forget what this is. This right here, isn't it x squared minus 1? So just do x times x squared minus 1 right here on the side of your paper. X cubed minus x. Then bring down your plus sign. Oh, now this is fun. This all cancels with up here. Woohoo! That's my favorite part. So now what do I just have left? X squared minus 5, whatever was in the numerator. This one cancels with this one. Ugh, but I have this x squared plus x plus 2 times x minus 1. All right, so we got a FOIL. It's not that bad. X to the x squared is x cubed. X times x is x squared. X times 2 is 2x. And then you do the negative 1. Oh, so that wasn't terrible. Wasn't as bad as I thought. All right, let's see what we can cancel from here to here. Because honestly, look, like I see an x cubed here and an x cubed here. Wouldn't you just subtract that over? So aren't they going to cancel? Negative x here, cancels. Anything else? These will not cancel. I know you think they will.
The one to the left.
Although that will cancel with that one. Woohoo! There we go. Anything else? No, I think I'm good. So x squared minus 5 equals 2x and a minus 2. Again, whenever you have a quadratic, set it equal to 0. That's really your best bet, y'all. X squared minus 2x minus 3. Let's see if we can factor. I'm pretty sure you can on this one. Two numbers that multiply to -3 but add to -2. -3 and 1, right? Okay, so what are my two answers then? 3 and -1? Are either of them going to cause me to have a 0 in the denominator up here?
Yes.
Which one?
-1.
Cross it off. That is extraneous. Your only answer is 3. That's it. Happy lesson. That's it. Okay. Can you do this? Of course you can. All right. So now you have your options for the rest of this class period. Your options are do the